Hello there, and welcome to the Sleepy Science Channel. I'm so glad you found your way here tonight. Maybe it's been a long day, or maybe you're someone who likes to drift to sleep with quiet wonder, letting thoughts of distant worlds replace the noise of daily life. There's nothing you need to do now but rest. Let your mind grow still, your breathing slow, and your body light. Because tonight, we're not just closing our eyes. We're traveling through the quiet, shimmering world shaped by the speed of light. From the earliest glow of the newborn universe to the gentle stretching of time itself. From photons drifting across galaxies to the dreamy possibilities of near-light travel. We'll explore 100 sleepy facts to help you relax, unwind, and drift into a calm night's rest. We'll wander through space-time, tiptoe along the edges of relativity, and listen to the soft stories carried by ancient starlight. Together, we'll follow the constant that binds the cosmos, learning how it shapes distance, time, and even the boundaries of what we can imagine. And if these calm explorations help you rest, consider liking and subscribing. It helps other sleepy travelers find their way here too. Now, close your eyes, and let's begin. Fact 1. The first flicker. Long before galaxies unfurled their spiraling arms, before stars took their first gentle breaths, the universe was a warm and glowing fog. In those early moments, light could not yet roam free. It was trapped, scattered endlessly by the dense sea of particles surrounding it. But as the cosmos expanded and cooled, the fog slowly thinned, like morning mist lifting from a quiet field. Eventually, the first photons slipped loose, finally allowed to wander. This ancient glow still drifts around us today, stretched into faint microwaves by the passage of time. It is the universe's oldest light, a soft echo of creation itself. And from that glow, everything we know began to shine, inviting us to follow the story forward. Fact 2. A constant in the cosmos. The speed of light, often written simply as c, is one of nature's most steadfast promises. No matter where you are in the universe, no matter how you move or how you watch, this speed remains the same. A quiet, unwavering rhythm woven into the fabric of existence. It travels at nearly 300,000 kilometers every second, a pace so swift that it almost defies imagination. This constancy gives the universe structure. It gives time its shape and distance its meaning. Even when light changes color, direction, or medium, its cosmic speed limit never wavers. Like a steady heartbeat in the vastness, the speed of light keeps the cosmos in balance, guiding us gently toward the mysteries it reveals next. Fact 3. The silent limit. Every motion in the universe, from drifting dust to swirling galaxies, is bound by a quiet rule. Nothing with mass can reach or exceed the speed of light. This limit isn't a wall or a barrier. It's more like the way shadows stretch but never quite touch the horizon. The closer an object tries to get to that ultimate speed, the more energy it needs until the requirement becomes infinite. Light itself travels at this limit because it has no rest mass. It is free to slip through space-time at full pace. Everything else must remain just a little slower, no matter how determined or powerful it becomes. And so, the speed of light stands as the universe's gentle boundary, pointing us toward the wonders that lie just beneath its threshold. Fact 4. Light's gentle footprint. Light is curious in its nature. It carries energy across the universe, yet it has no rest mass at all. A photon drifts weightlessly, like a tiny note in an endless symphony, able to move at full cosmic speed precisely because nothing anchors it in place. Though massless, it still leaves a quiet influence wherever it goes, nudging electrons, warming surfaces, inspiring life to grow. What makes this even more soothing is how subtle that influence can be. A single photon hardly disturbs the world, but in great numbers they paint the heavens with color, warmth, and motion. They remind us that even the gentlest of things can fill a universe, and from that softness, we journey onward. Fact 5. A beam's long journey. It's easy to think of light as fleeting, but imagine what happens in just 1 second. In that tiny heartbeat of time, a beam of light sweeps around Earth 7.5 times. In the next second, it races past the moon's orbit. Give it a minute, and it's already out beyond the reach of Earth's gravity, sailing through interplanetary dark like a sprinter who never tires. This speed is so immense that it becomes almost serene, a kind of cosmic glide. Light doesn't rush or strain, it simply moves, effortlessly and eternally. And as it continues its quiet journey, it leads us toward deeper distances, where even a single second becomes a measure of wonder. Fact 6. Ripples through vacuum. One of the most elegant things about light is that it doesn't need anything to carry it along. Sound requires air, waves need water, and objects rely on surfaces. But light can travel through perfect emptiness. It moves as a ripple in the electromagnetic field, a gentle oscillation that doesn't depend on atoms or molecules. Space itself becomes its pathway. This makes the universe feel more open, more connected. Even across the vastest emptiness, light can bridge the silence, reaching from star to star without growing weary. It reminds us that even in the quietest void, something can still move. And where light moves, new discoveries wait in the darkness ahead. Fact 7. The ocean of space. Although we often imagine space as empty, it holds an invisible ocean, a quiet electromagnetic field that stretches everywhere. Light travels as a wave upon this vast sea, rising and falling in delicate rhythms. Even in non-asymptotic regions where no matter exists, this field remains, giving every photon a path to follow. It's as though the universe provides its own gentle water, allowing light to drift with effortless grace. When we picture light moving through this cosmic ocean, it becomes easier to feel the softness of its motion, steady, calm, unhurried. And as we follow these smooth ripples, we begin to sense the harmony that guides the universe onward. Fact 8. Colors of speed. White light may seem simple, but within it lies a full chorus of colors. Deep reds, soft greens, brilliant blues, each created by waves of different lengths. Yet no matter their hue or tone, all these colors travel at the same universal speed in the vacuum of space. A long, slow red wave and a quick, tight blue one arrive together, perfectly synchronized by nature's design. This equality is part of what makes light feel so balanced. Even as its colors spread into rainbows or drift through nebulae, their shared speed binds them into a single, unified story. And from this chromatic harmony, we drift gently into the next wonder, waiting in the dark. Fact 9. The time light. Takes light may be swift, but even it needs time to cross the great distances of space. We often measure astronomical journeys not by kilometers, but by light seconds, light minutes, and light years. Gentle markers of how long a photon has been traveling. A light second is just the blink of an eye. A light year is a patient wanderer's tale, carried across the silent cosmos. These units remind us that distance and time are intertwined. To look outward, is to look backward, receiving old messages from faraway places. Every beam that reaches us has taken its own quiet journey, and each one leads us farther, toward the next soft whisper of the universe. Fact 10. The whisper to the moon. Even our closest celestial companion, the moon, lies far enough away that light needs time to reach it. A photon leaving Earth takes a little over 1 second to make the journey. A brief pause, yet long enough to remind us how spacious even our neighborhood truly is. When you gaze at the moon, you're seeing it as it was moments before, its soft glow delayed by the slightest whisper of time. This delay is gentle, almost poetic. A second is hardly noticeable to us, yet for light, it is a measurable voyage across a vast gulf. And as we follow this quiet step outward, we prepare to move from our small world into the greater stories of the sun. Fact 11. The sun's slow escape. We often think the sunlight touching our skin was born just 8 minutes ago, but the truth is far more patient and serene. Deep inside the sun's core, photons begin their lives amid unimaginable density. They collide, scatter, and ricochet through layers of plasma for tens of thousands of years, sometimes even longer, before finally reaching the surface. What emerges as warm, comforting sunshine has survived a maze of chaotic motion. Only when a photon breaks free of the sun's outer layers can it travel straight through space at full speed. So the light of each new day is ancient at its heart. A slow, luminous traveler, finally stepping into the open. Fact 12. The daylight dash. Once sunlight escapes the surface of the sun, its journey becomes breathtakingly swift. Only 8 minutes and 20 seconds lie between the star that warms us and the world we call home. In those few minutes, a photon crosses nearly 150 million kilometers, racing over solar winds, passing planets, and gliding effortlessly through the vacuum. This short delay means the sunlight you see is always slightly old, a tiny echo from the recent past. Yet nothing feels outdated about its warmth. The sun shines steadily, and each beam that reaches Earth carries the same calm message of life, energy, and continuity. And as we linger in that glow, the next quiet truth waits in the soft space between moments. Fact 13. Morning on delay. Every sunrise arrives to us on a gentle delay. The golden edge that climbs over the horizon each morning began its journey more than 8 minutes earlier, leaving the sun long before you opened your eyes to greet it. Even those first warm rays that spill across rooftops and treetops are quiet messengers from the recent past. They traveled through calm space, unhurried and true, to touch our world just in time to greet the day. This delay is one of nature's softest illusions, a reminder that we live ever so slightly behind the universe's present moment. And with that understanding, we drift deeper into the long, ancient stories carried by starlight. Fact 14. Starlight's ancient tale. When you look up on a clear night and see a star twinkling gently in the darkness, you're witnessing a moment pulled from history. Some of the stars overhead shine from tens, hundreds, or thousands of light years away. Their glow began its journey long before entire civilizations rose and faded on Earth. Each photon that reaches your eye tonight left its home long before you ever took your first breath. This ancient light is a kind of cosmic time capsule, preserving the memory of distant suns as they once were. The night sky becomes a quiet library of long-traveled stories. And as we listen to those whispers from afar, we move toward wonders even older still. Fact 15. Galaxies through time. A single star may send us a message from centuries ago, but entire galaxies speak across millions or billions of years. When our telescopes peer into deep space, they are also peering into deep time, catching light that began traveling when Earth was young, or even before Earth existed at all. The spirals, clusters, and glowing clouds we see far away are not as they are now, but as they once were, preserved in the patient language of light. This means that every distant galaxy offers us a window into an earlier chapter of the universe, a chapter still shimmering quietly across the void. And as we follow those faint, ancient glimmers, we step gently toward the next soft truth waiting in the cosmic dark. Fact 16. A universe in snapshot. Every time we capture an image of the night sky, we are photographing moments that no longer exist. A telescope doesn't just look outward, it looks backward. The light it collects may have started traveling when mountains were still forming, when oceans were settling, or when Earth itself was only a swirling cloud. These snapshots freeze ancient instants, allowing us to witness scenes long vanished from the present universe. Each picture becomes a gentle reminder that time flows differently across the cosmos. The universe reveals itself to us one delayed shimmer at a time, unfolding like the pages of an old, cherished book. And as we turn those pages, we drift toward even fainter, older whispers of creation. Fact 17. Light's faint memory. Light has a way of remembering. A photon, released from a distant star, holds within it the conditions of its birthplace, the temperature, the energy, the motion of the star at that moment. As it travels across unimaginable distances, it carries those memories without fading. Even after billions of years, a photon can arrive at Earth, still bearing the imprint of its origin. Astronomers read these memories like soft poems written in color and energy. A star's age, its motion, even its story by the time the photon departed, all of this is contained within that single ancient traveler. And as these faint messengers drift into our telescopes, they lead us gently toward the oldest light of all. Fact 18. Distant echoes. Long before galaxies formed, before the first stars flickered awake, the newborn universe glowed with a warm, uniform light. Over billions of years, this radiation stretched and cooled until it settled into the gentle microwaves we observe today. This glow, known as the cosmic microwave background, surrounds us like a quiet echo of creation. It is the oldest light we can see, a soft veil left behind by the universe's earliest moments. When scientists study this faint glow, they hear whispers from the dawn of time, tiny variations that map the seeds of galaxies yet to come. And from these ancient echoes, we drift calmly toward new truths woven into the fabric of space-time. Fact 19. A glow, older than stars. Before the first stars ever shimmered awake, the universe was already filled with a soft radiance, a gentle glow from the moment the cosmos became transparent. This ancient light, still drifting today as the cosmic microwave background, predates every galaxy, every cluster, every world that would one day form. It is a reminder that illumination came before structure, that the universe began not in darkness, but in a warm, pervasive brightness. This glow has been stretched by time, thinned by expansion, but never extinguished. It is the universe's oldest surviving message, a quiet breath from a time when everything was newborn. And from this primordial light, we begin to approach the deeper workings of the space it moves through. Fact 20. The fabric beneath. Light does not simply wander freely. It follows the curves and contours of space-time itself. The universe is not a flat emptiness, but a subtle fabric that bends and stretches under the influence of mass and energy. Every photon traces the shape of this fabric, gliding along the smooth paths carved out by stars, planets, and galaxies. Even in perfect darkness, space-time offers a silent roadmap for the traveler that light becomes. When we picture this fabric, we can imagine a vast, soft sheet gently molded by the weight of celestial bodies. Light drifts over these contours like a quiet stream navigating gentle hills. And as we study these curves, we step into the realm where time and motion intertwine. Fact 21. Time and speed. Entwined. Time and speed are woven together more closely than they first appear. According to Einstein's insight, the faster something moves through space, the slower it moves through time. For objects nearing the speed of light, this effect becomes profound. Clocks tick more slowly, distances seem to shrink, and moments stretch into long, serene intervals. To a fast-moving traveler, the universe changes its rhythm, softening the passage of time. Light itself experiences something even stranger. From a photon's perspective, no time passes at all. Its journey across billions of years feels instantaneous. And as we follow this gentle bending of time, we prepare to explore the deeper mysteries waiting just beyond the threshold of light's swift domain. Fact 22. The closer to light you go. As an object moves faster and faster, edging closer to the speed of light, its experience of time begins to stretch like a soft, elastic thread. Seconds for an outside observer may drift into long, lingering moments for the traveler. The closer the motion approaches light speed, the more exaggerated the effect becomes, until time almost seems to pause. This transformation isn't felt harshly. Instead, it unfolds quietly, like a slow ripple through existence. To imagine this is to imagine slipping into a gentler rhythm, where moments lengthen and the universe appears to breathe more slowly. And as we explore this slowing of time, we step toward one of science's most peaceful paradoxes. Fact 23. A traveler's dream. If a person could journey through space at nearly the speed of light, their experience of the universe would feel profoundly different. Time aboard their ship would move at a serene, unhurried pace, while the outside world rushed forward in great leaps. Years might pass for those watching from home, while only months or days drifted by for the traveler. To them, the stars ahead would draw closer more quickly, their distances gently compressed by the nature of relativity. This dreamlike effect makes high-speed travel feel almost magical, though it is rooted in deep physical truth. A journey at such speeds becomes a quiet dance between motion and time. And in this dance, we find the seeds of a famous thought experiment waiting softly ahead. Fact 24. The paradox of twins. One of the most soothing ways to imagine time dilation is through the twin paradox. Picture two siblings. One remains on Earth, while the other travels on a near-light-speed voyage among the stars. The traveling twin experiences time more slowly, aging gently, almost leisurely, while the sibling on Earth ages at the normal pace. When they reunite, the traveling twin is noticeably younger, not through any illusion, but through the natural, graceful flow of relativity. This scenario is not a contradiction, nor a trick. It is simply the way space-time behaves when motion bends the rhythm of time. And from this peaceful paradox, we glide toward even deeper mysteries about mass, energy, and the nature of motion itself. Fact 25. Mass in motion. As an object moves faster, edging closer to the speed of light, something gentle but profound begins to happen. It becomes harder and harder to accelerate, not because the object grows heavier in the ordinary sense, but because its energy resists change. Physicists sometimes describe this as mass increasing with speed, though it is really energy weaving more tightly into the object's motion. The faster you try to push, the more the universe quietly reminds you of its limits. This effect protects the speed of light, making it unreachable for anything with mass. It is nature's way of keeping time, motion, and energy in harmony. And from this slowing resistance, we drift toward the timeless world of light itself. Fact 26. Light's ageless voyage. One of the most serene truths in physics is that a photon, a particle of light, experiences no time at all. From its perspective, there is no ticking clock, no waiting, no aging. A photon, born in the heart of a distant galaxy, may travel for billions of years before reaching us. Yet to the photon, the journey is instantaneous. It leaves, it arrives, and nothing in between passes. This timelessness gives light its ethereal quality, as though it moves outside the rhythms that govern the rest of the universe. Light is both ancient and forever young. And in considering this, we step into the stillness of a moment, frozen at the speed of light. Fact 27. A frozen moment. To imagine life at the speed of light is to imagine existing in a single eternal moment. Distances vanish. Clocks stop. The entire path of a photon, from origin to destination, collapses into a single point of experience. Although we, confined by mass, can never share that perspective, we can picture it gently. A world where motion and time are so deeply entwined that one erases the other. This frozen moment isn't frightening or strange. It's peaceful, like a breath held in perfect stillness. It reminds us how differently the universe can appear depending on how we move through it. And from this quiet vision, we step onward toward the ways we've learned to measure something so impossibly swift. Fact 28. Measuring the swift. Measuring. The speed of light has always been a gentle challenge for curious minds. For most of human history, light seemed far too swift to time. It appeared to move instantly, leaving no gap between the spark and the seeing. Yet scientists kept searching for ways to capture that fleeting motion, using clever setups and careful observations. Their attempts were like trying to catch a whisper in the wind, subtle and patient. And slowly, bit by bit, they learned that even the swiftest thing in the universe leaves small clues behind. Those clues guided us toward the first true measurement, and to the astronomer who made a discovery by watching a distant moon. Fact 29. Rømer's celestial clock. In the 1600s, the Danish astronomer Ole Rømer noticed something unusual about Jupiter's moon Io. Its eclipses didn't always appear on time. Sometimes Io slipped into Jupiter's shadow earlier than expected. Other times, it lagged behind. Rømer realized that the difference came from Earth's changing distance as it orbited the Sun. When Earth was farther away, Io's eclipses appeared late, because the moon's light took a little longer to reach us. This was the first real evidence that light had a measurable speed. Rømer used the heavens themselves as a clock, letting a distant moon reveal a cosmic truth. And from this celestial timing, scientists began refining their measurements with earthly tools. Fact 30. A spinning mirror's secret. In the 1800s, physicists turned to ingenious instruments to measure the speed of light more precisely. One famous method used a spinning mirror. A beam of light bounced off the moving surface, traveled a short distance, then returned to the mirror, which had rotated slightly in the meantime. By noting the tiny shift in the beam's direction, scientists could determine how fast the light had traveled on its round trip. The idea was simple, yet exquisitely delicate, like watching the tilt of a leaf to learn the direction of a breeze. Through these experiments, humanity came closer to locking down nature's most fundamental speed. And with that new understanding, we stepped gently into the era when equations began revealing light's deeper secrets. Fact 31, Maxwell's quiet prediction. Long before anyone fully understood the nature of light, James Clerk Maxwell wrote down a set of equations that described how electric and magnetic fields behave. When he combined them, something remarkable emerged. These fields could create waves that traveled through space, and the speed of those waves matched the speed of light. Maxwell realized with gentle certainty that light itself was an electromagnetic ripple. This discovery was less a sudden spark and more a serene unfolding, mathematics revealing a hidden harmony. Light, electricity, and magnetism were not separate phenomena at all, but part of one elegant unity. And from that unity, we drift softly into the varieties of light that share the same universal speed. Fact 32. Waves of every kind. Though we see only a sliver of light with our eyes, the electromagnetic spectrum stretches far beyond the colors of the rainbow. Long radio waves drift through space like slow, calm breaths, while short, energetic gamma rays flicker with barely restrained intensity. Yet no matter their wavelength, whether wide and lazy or tight and sharp, they all travel at that same gentle cosmic speed in a vacuum. This sameness binds them like members of one extended family, different personalities, but guided by the same rhythm of the universe. When we tune a radio, gaze at a star, or receive an X-ray, we are touching different notes of the same quiet symphony. And following these notes, we arrive at the places where light slows down and bends. Fact 33. Transparent pathways. While light races effortlessly through the vacuum of space, it moves more slowly through materials like air, water, or glass. This isn't because the photon grows tired or hesitant, but because it interacts gently with the atoms it passes. Each interaction delays the journey ever so slightly, creating a softer, slower pace. In glass, for instance, light may travel almost twice as slowly as in a vacuum, turning a rapid dash into an elegant stroll. These delays give rise to reflections, refractions, and all the small wonders that let us see the world's shapes and colors. Light adapts to its surroundings with grace, never forcing its way through, only adjusting its rhythm. And from this softened pace, we drift toward the beautiful bending of light that comes next. Fact 34. Dancing through water. When light enters water, it slows down and bends, changing direction as though it were stepping from one kind of world into another. This bending, called refraction, happens because the gentle vibrations of photons interact with the molecules of the liquid. The shift is subtle, a quiet nudge that redirects light's path, curving it like a soft gesture. This is why objects beneath the surface look slightly displaced, shimmering, or closer than they truly are. Watching light drift through water is like watching a dancer adjust her movements to a new rhythm, graceful and effortless. And as we follow these quiet curves, we approach the mirages and illusions that light paints across warm horizons. Fact 35. The mirage of speed. Mirages are delicate tricks born from the bending of light through layers of air at different temperatures. On a hot day, the air near the ground warms and rises, creating gradients that coax light into wavy, unexpected routes. The result is the illusion of water where none exists, or distant landscapes reflected like pale ghosts on the surface of a road. Though the scene appears magical, it is simply light exploring the changing density of the air. This wandering, this soft distortion, shows how sensitive light is to its surroundings. Even the faintest shift in temperature can guide a beam into a gentle arc. And from these shimmering illusions, we drift toward the experiments that once slowed light almost to a stop. Fact 36. Slower than a whisper. Though the speed of light in a vacuum is the universe's highest limit, researchers have learned how to slow it dramatically inside special materials. In certain ultra-cold gases, light can be coaxed into creeping along at the pace of a slow walk, or even brought temporarily to a halt. This doesn't mean photons freeze in place. Rather, they blend gently with the atoms around them, storing their presence like a lingering echo. This remarkable effect shows how flexible light can be when it interacts with matter. Even something so famously swift can become tender and patient under the right conditions. And from this soft slowing of light, we step into the mysterious world where photons behave as both waves and particles. Fact 37. The nature of photons. A photon is one of the universe's most delicate creations. Not quite a wave, not quite a particle, but something softly suspended between the two. When we describe light as a wave, we picture gentle ripples moving through the electromagnetic field. When we describe it as a particle, we imagine tiny packets of energy arriving one by one. A photon is both, yet fully neither, existing in a form that defies the rigid categories we're used to. This dual nature isn't a contradiction. It's simply the universe expressing itself in a more fluid, graceful language. And as we linger with this fragile idea, we drift toward the even finer grains that make quantum light shimmer. Fact 38. The soft grain of reality. On the quantum scale, the world becomes a place of gentle uncertainty. Light doesn't travel as a smooth, continuous stream. Instead, it arrives as discrete quanta, tiny bursts of energy that appear where they are probabilistically expected, never in perfect certainty. A photon doesn't decide its path ahead of time. Instead, it drifts in a cloud of possibilities, settling into a single location only when observed. This granularity gives reality a soft, shimmering texture at its smallest scales, as though everything is woven from countless subtle threads. Quantum physics doesn't strip away comfort. It adds mystery, revealing that even the simplest beam of light contains infinite delicate choices. And from this shimmering uncertainty, we meet the idea that photons carry energy in tiny, perfectly measured packets. Fact 39. Light's hidden quanta. Every photon carries its energy in a precise and beautifully simple way. The shorter its wavelength, the more energy it holds. A deep red photon arrives with a gentle touch, while a violet or ultraviolet photon carries a bit more intensity, like a slightly brighter note in a cosmic melody. This quantized nature of light is what allows photosynthesis to begin, solar panels to work, and atoms to release their own soft glows when excited. It's astonishing how much the universe accomplishes through these tiny packets, how each photon's energy helps shape stars, fuel chemistry, and illuminate worlds. And with this understanding, we glide toward the truth that even light's path cannot be known with perfect clarity. Fact 40. The uncertainty drifts. In the quantum world, even a photon's path cannot be pinned down with perfect precision. The more carefully we try to know where a photon is, the less clearly we can know how it is moving. And the reverse is also true. This isn't a flaw in our instruments, but a gentle rule built into the fabric of reality. Light drifts through space in a haze of possibilities, settling into place only when nature quietly chooses a single outcome. This uncertainty softens our sense of motion, turning every journey into a cloud of potential paths. It's as if the universe prefers openness to rigid certainty, allowing countless possibilities to shimmer until one becomes real. And from this delicate indeterminacy, we glide toward the way gravity touches even these threads of light. Fact 41. Gravity's gentle grip. Though photons have no rest mass, gravity still influences their paths. Massive objects like stars, galaxies, and black holes bend space-time itself, shaping the routes that light can follow. A photon moves straight from its own perspective, yet these straight lines of space-time curve around heavy bodies, guiding light like a quiet hand guiding a flowing stream. This bending is subtle across short distances, but profound near immense gravitational wells. To imagine this is to picture light as a graceful traveler gliding along invisible contours carved into the cosmos. Its path changes not because it hesitates, but because the space beneath it gently slopes. And from this gentle curvature, we approach the moment when starlight revealed this truth to the world. Fact 42. The arc around stars. In 1919, during a total solar eclipse, astronomers observed starlight passing close to the sun and found that the star's apparent positions shifted ever so slightly. This wasn't because the stars themselves had moved, but because their light had curved around the sun's gravity on its way to Earth. The eclipse dimmed the sun's glare, revealing this tiny but profound effect predicted by Einstein's theory of general relativity. It was a quiet confirmation, written in the faint arcs of distant starlight. Space-time truly bends, and light follows those curves like a soft ribbon drifting in a slow wind. And from this stellar arc, we continue toward even grander distortions, where entire galaxies act as cosmic lenses. Fact 43. A lens made of space. When light passes near massive galaxies or clusters of galaxies, space-time around them curves so deeply that the distant light is stretched, magnified, or split into multiple shimmering images. This effect is known as gravitational lensing, and it turns the universe itself into a quiet, natural telescope. Faraway galaxies that would otherwise be invisible become softly outlined by the way their light bends through these grand cosmic structures. The lensing isn't sharp or abrupt. It's gentle, like watching moonlight refract through a curved piece of glass. These distant distortions reveal hidden beauty, showing us galaxies as they were billions of years ago. And from these magnified whispers, we drift toward the ways gravity shapes not only paths, but time itself. Fact 44. Time slowed by gravity. Gravity doesn't only bend the routes that light takes, it also stretches and slows the flow of time. Near a massive object, a planet, a star, or especially a black hole, clocks tick a little more slowly than they do farther away. This effect is subtle on Earth's surface, so faint we never feel it, but it becomes profound in stronger gravitational fields. Time flows like a soft river, its pace changing depending on the slopes carved by mass. To picture this, imagine two clocks, one high above Earth and one resting quietly on the ground. The higher clock runs a touch faster, lifted away from gravity's gentle pull. And from this slowing of time, we move toward the way light changes as it climbs out of gravity's well. Fact 45. Light in a gravity well. When light escapes from a region of strong gravity, it loses a bit of its energy, stretching into redder, softer wavelengths. This gentle shift, known as gravitational redshift, doesn't dim the photon's spirit. It simply reflects the work done to rise out of gravity's embrace. A beam climbing away from a dense star or galaxy drifts into a longer, calmer color as it emerges. This shift helps astronomers understand the strength of gravitational fields across the cosmos. From bright stars to compact neutron stars, their gravitational pull can be read in the soft stretch of escaping light. And with this understanding, we float toward the larger cosmic motions that stretch light on even grander scales. Fact 46. The shifting colors of space. As the universe expands, light traveling through it becomes gently stretched, its wavelengths pulled toward the red end of the spectrum. This effect, called cosmological redshift, happens not because the light slows down or grows tired, but because the very fabric of space stretches beneath it. A photon that once shimmered in bright blues may arrive at Earth as a soft red, changed only by the growing distance it has crossed. This stretching is like a whisper carried across an ever-widening valley. The message remains, but its tone becomes deeper and more mellow with time. And from this shifting color, we drift into the way time itself appears to stretch across cosmic distances. Fact 47. The stretch of time itself. When we peer far into the universe, we don't just see light that has been stretched. We witness time that has been stretched as well. Distant galaxies appear to move more slowly, not because their own clocks have changed, but because the expansion of space lengthens the intervals between the light waves they send us. Events that once unfolded quickly seem to drift at a gentler pace when viewed from across billions of light years. This time, dilation on cosmic scales is soft and subtle, a quiet reminder that the universe we observe is shaped not only by what is happening, but by how long the light takes to reach us. And as we follow this slowing of distant moments, we approach the limits of what we can ever hope to see. Fact 48. Horizons we cannot cross. No matter how powerful our telescopes become, the universe has an observable edge, a horizon formed by the limits of light's long journey. Beyond a certain distance, the expansion of space outpaces even the speed at which light can reach us. Those regions remain forever hidden, not because they are dark, but because their light can never bridge the widening gulf between us. This horizon is like a gentle curtain drawn across the farthest reaches of existence. Behind it, galaxies continue to drift. Stars are born and die, and cosmic stories unfold that we will never witness. And from this quiet boundary, we move toward the fate of the lonely photons that will never find their way to our corner of the cosmos. Fact 49. Light lost to the void. Not all light manages to complete its journey. Some photons, born in distant galaxies, are carried along on the currents of expanding space so swiftly that they never reach us at all. They drift endlessly, stretch thinner and softer with time, their wavelengths lengthening until they fade into faint, whispering waves. These photons are not destroyed. They simply travel into regions from which no message can ever return. It is a peaceful kind of disappearance, a gentle fading rather than an abrupt end. Light becomes part of the quiet background of the cosmos, continuing its journey even if no one will ever see it. And from this endless drift, we turn toward the dark, expanding future that pulls galaxies ever farther apart. Fact 50. The ever-expanding dark. The universe is growing larger every moment, with galaxies retiring into the distance like lanterns drifting across an enormous sea. As space stretches, the light traveling through it becomes fainter and more elongated, slipping into longer and cooler wavelengths. Over vast timescales, distant galaxies will fade from view entirely, not because they're gone, but because their light is stretched beyond detectability. This expansion is gentle, almost imperceptible in our daily lives, yet its cumulative effect shapes the fate of the cosmos. The night sky we know is only a temporary arrangement, a fleeting pattern in an ever-widening universe. And as we imagine this growing distance, we step into how the speed of light shapes the very structure of reality. Fact 51. The speed that shapes reality. The speed of light is more than a number. It is the foundation upon which the universe builds its rules. It sets the maximum rate at which information can travel, defining what events can influence each other and which are forever separated. Without this constant speed, cause and effect would lose their order, and the symmetry of physical laws would unravel. Light acts as the quiet metronome of existence, ticking out the pace of cosmic interactions. This limit isn't restrictive. It creates harmony. It gives space-time its geometry, time its rhythm, and reality its shape. And from this cosmic foundation, we drift toward the elegant concept that describes how influence spreads through space-time itself. Fact 52. Light cones of possibility. Every event in the universe sends a quiet ripple of influence outward at the speed of light, forming what physicists call a light cone. Inside this cone are all the places that the event can reach, and all the places that can one day respond. Outside, it lie regions forever untouched, separated not by walls or obstacles, but by the simple limit that nothing travels faster than light. It is a gentle way of understanding who can speak to whom across the cosmos. When we imagine these cones overlapping and expanding, we see a universe stitched together by light's patient timing. And from these ripples, we drift into the realization that now is not the same everywhere. Fact 53. The present is not the same everywhere. We often speak of the present moment as if it is shared by all things. But in the vastness of space, now becomes a softer, fluid idea. Two observers moving differently through space may disagree on which events happen at the same time. A flash of lightning on a distant moon, a star's gentle flicker, even the pulse of a neutron star. All of these can appear in different orders depending on one's motion. This doesn't make time chaotic. It makes it beautifully relative. Each observer experiences a slightly different tapestry of moments woven from their unique path through space-time. And from this shifting sense of now, we begin to understand how softly the universe balances perspectives. Fact 54. Time's gentle relativity. Einstein's insight into time was not harsh or abrupt. It was as soft as watching two clocks drift out of sync because their journeys differ. A clock aboard a satellite ticks a little faster than one on Earth's surface. A clock on a fast-moving rocket ticks more slowly than one at rest. These differences are tiny but real, and they accumulate with distance and speed, creating a world where time is not rigid but responsive. This gentle relativity is woven into our everyday lives, guiding technologies like GPS and shaping our understanding of cosmic motion. Time is not a single river, but many small streams, each flowing at its own pace. And from this multiplicity of time, we approach the way light becomes our messenger between worlds. Fact 55. The universal conversation. Light is the soft language the universe uses to communicate across distance. Every star that shines, every atom that glows, every galaxy that flickers sends out photons carrying tiny messages about their temperature, motion, and age. These beams travel patiently through the dark, never rushing, never pausing, whispering their stories to anyone or anything capable of catching them. Even across billions of years, their messages remain remarkably faithful. In this way, light becomes a universal conversation, connecting distant corners of the cosmos through a gentle exchange of information. And from this quiet dialogue, we drift toward the limits of what information can ever say. Fact 56. The limits of knowing. Because nothing can travel faster than the speed of light, there are boundaries to what any observer can learn about the universe. These limits aren't harsh. They simply reflect the time it takes for information to arrive. A distant planet may host storms or sunsets, but we learn of them only after light has carried their story to us. The farther away something lies, the older the information becomes, wrapped in the gentle delay of cosmic travel. This delay creates a peaceful patience in our understanding, a willingness to wait for the universe to speak in its own time. And from this quiet boundary, we turn to something even more curious: shadows that seem to outrun light itself. Fact 57. The speed of darkness. Shadows can stretch across surfaces faster than the speed of light, racing along walls or sweeping over distant landscapes in an instant. But this seemingly impossible motion carries no information at all. The shadow is simply the absence of light, not a physical thing that moves. Because a shadow transmits no signal, it is free from the cosmic speed limit, slipping like a quiet illusion across whatever surface it touches. This gentle distinction reminds us that not everything that appears fast is truly traveling. Some things are just patterns shifting across the canvas of light. And from this distinction between what moves and what only seems to move, we drift toward imagining a universe where light itself behaved differently. Fact 58. A universe without light. Imagine a universe where light had no speed or no existence at all. Without light to carry information, the cosmos would feel strangely silent. Objects could not see or sense one another across distance. Stars might form and burn, but nothing could witness their glow. Time would lose one of its most gentle markers, and space would be stripped of the shimmering stories that photons bring. The universe would still evolve, but its beauty would remain hidden, unshared. Such a universe would be quiet in a way ours never is. Everything would still happen, yet nothing would ever be known beyond its immediate surroundings. And from contemplating this quiet emptiness, we turn back to the comfort of light as the ruler of space and time. Fact 59. Light as a cosmic ruler. The speed of light isn't just a number written in textbooks. It defines the very structure of measurements we use. Our definition of a meter, for example, is based on how far light travels in a tiny fraction of a second. Time and distance are stitched together by this constant speed, making light the universe's gentle measuring stick. Every clock tick, every astronomical observation, every precise instrument relies on this cosmic ruler. It's beautiful in its simplicity. To understand space, we look at light. To measure time, we watch the rhythm of photons. And from this elegant unity, we drift toward the moment humanity chose to anchor this constant forever. Fact 60. The constant. We chose. In 1983, scientists made a quiet but profound decision. They defined the speed of light as an exact value, not something to be measured and remeasured, but a constant woven permanently into our understanding of physics. By fixing its speed, they allowed the definition of the meter to be tied directly to time, making all future measurements consistent and stable. This choice didn't change the universe. It simply acknowledged the unwavering reliability of light. It was a moment of harmony between human understanding and cosmic truth, an agreement that light would forever be our guide. And from this foundation, we move gently into the ways light now carries our voices, thoughts, and data across the modern world. Fact 61. Fiber optic. Murmurs. Beneath our cities, across mountains, and under the quiet expanse of oceans, thin strands of glass weave a glowing network. Inside these delicate fibers, pulses of light carry our words, searches, stories, and songs. A single beam can travel astonishing distances without losing its clarity, bouncing gently along the inner walls of the cable. It moves silently, almost tenderly, guiding information with the soft precision only light can provide. This global web of illumination connects billions of people, turning distant continents into next-door neighbors through shimmering threads. And from these murmurs beneath our feet, we continue to the vast waters where those threads stretch even farther. Fact 62. Pulses beneath the ocean. Deep below the waves, where sunlight never reaches and the world drifts in calm blue darkness, lie thousands of miles of fiber optic cables. Within them, light travels tirelessly, darting across the ocean floor to link nations and continents. Every moment, these faint pulses carry messages across immense distances, crossing trenches and ridges with peaceful ease. Even in the cold stillness of the deep sea, light remains a gentle messenger. It's soothing to imagine that even in the most silent parts of the earth, tiny photons are gliding through glass tunnels, stitching our world together. And from these submerged pathways, we rise into the skies, where light keeps our navigation steady and true. Fact 63. Satellites that need time. Orbiting high above Earth, satellites quietly watch our world and help us find our way. Systems like GPS depend not just on radio signals, but on the delicate dance of time. Each satellite carries precise clocks that tick differently from those on Earth. Their speed and altitude shift the flow of time just enough that, without correction, navigation would drift wildly. Light brings their signals down to us, guiding travelers, pilots, ships, and phones with calm, unwavering consistency. It's a gentle reminder that even in everyday life, relativity is hard at work, shaping the timing of the signals that help us move through the world. And from these time-tuned satellites, we drift toward the many other ways light keeps our technology in harmony. Fact 64. A web of beams. Across laboratories, observatories, and quiet research centers, lasers hum softly, sending out perfectly aligned beams of light. These beams act as rulers, communicators, and guardians of precision. In science experiments, they measure distances smaller than atoms. In communication systems, they carry streams of data through the air. And in observatories like LIGO, they detect tiny ripples in space-time by comparing the lengths of laser paths with exquisite sensitivity. Lasers are calm, orderly rivers of photons. Their light steady, dependable, and unwavering. And from these guided beams, we drift toward a gentler, more delicate use of light: medicine. Fact 65. Light in medicine. Light has long helped us understand the body in ways that feel almost magical. Gentle flashes reveal fractures in bones. Glowing dyes highlight cells, and soft beams scan organs without ever touching them. Optical instruments look into the eyes, mapping tiny structures with breathtaking clarity. Even therapies using light can ease pain, heal tissues, or treat illness with precision that feels both modern and serene. In all of these ways, photons become quiet healers, traveling softly through the body, illuminating without harming, guiding doctors with their clarity. And from this healing glow, we arrive at a tool that uses light not just to observe, but to hold. Fact 66. Trapping. Starlight. Optical tweezers are one of the most delicate inventions in science. They use focused beams of light to hold tiny objects in place. A photon may be weightless, but its momentum is real. And when gathered in a tight beam, it can nudge microscopic particles with surprising gentleness. Scientists use this soft touch to trap cells, viruses, and even individual molecules, allowing them to study nature at its smallest scales. It's a peaceful kind of control. No forceful grip, no harsh pressure, just the quiet guidance of concentrated light. And from this intricate dance of photons and particles, we drift naturally into the mysterious realm of quantum communication. Fact 67. Quantum teleportation. In the quiet world of quantum physics, information can leap between particles in a way that feels almost magical. When two particles become entangled, their states remain linked no matter how far apart they drift. Through this connection, scientists can teleport the state of one particle to another, not by sending matter, but by transferring information through careful measurements and the gentle exchange of photons. This process doesn't break the cosmic speed limit. It simply uses the delicate choreography of quantum rules. The particles seem to whisper to each other through shared history, not distance. And from this subtle teleportation, we drift toward the equally mysterious threads that bind quantum communication to the speed of light. Fact 68. The delicate threads. Even in the strange quantum realm, nothing sends information faster than light. Entangled particles feel connected, but the moment we try to use their connection to send a message, we run into a quiet limit. The final step in quantum communication, confirming the result, still requires a classical signal that moves no faster than the speed of light. In this way, the universe maintains its gentle boundary, ensuring harmony between quantum strangeness and cosmic structure. This delicate balance protects causality, keeping past and future in their proper places. Entanglement may feel magical, but its magic respects the rhythm set by light. And from these gentle constraints, we drift toward the way photons can carry messages only you and I can read. Fact 69. Light's code. When photons are used in quantum communication, each one can carry a bit of information encoded in its polarization, the direction in which its wave gently oscillates. If anyone tries to intercept or measure these photons, their properties change, revealing the intrusion instantly. This makes quantum communication one of the safest ways to send secret messages, guarded not by locks or passwords, but by the laws of nature themselves. It's remarkable to imagine a message traveling across fibers or through open air, protected by the fragile, shimmering behavior of single photons. And from this secure whispering of light, we drift toward a future where entire computers might run, not on electrons, but on beams of illumination. Fact 70. The future of photonic worlds. In the computers of tomorrow, electricity may play a quieter role, while light takes center stage. Photonic computing uses beams of light rather than streams of electrons to carry information. Because photons don't bump into one another the way electrons do, they can move through circuits with almost no heat, no resistance, and remarkable speed. Entire calculations could unfold in a graceful dance of colors and pulses, humming along with gentle efficiency. This shift would allow processors to work cooler, faster, and more harmoniously, as though guided by the calm rhythm of light itself. And from imagining these luminous machines, we drift toward the limitations of our own motion through space. Fact 71. The fastest we can fly. Even our most powerful spacecraft move at a pace that feels serene compared to the speed of light. Probes like Voyager and New Horizons sail through the darkness at tens of thousands of miles per hour, astonishing by human standards, yet slow in the cosmic scale. If light were a runner crossing a room in an instant, our spacecraft would be like gentle walkers, taking their time across the same space. This difference reminds us how vast the universe truly is. Stars remain distant, not because we lack imagination, but because the cosmos is so wide that even our swiftest machines travel like drifting leaves on a quiet breeze. And from this humble speed, we turn toward dreams of starships that might one day approach light's great pace. Fact 72. Near-light starships. If humanity ever builds vessels that travel near the speed of light, they will glide through space in ways that feel almost otherworldly. Such ships might rely on advanced engines, exotic fuels, or even entirely new forms of propulsion. As they accelerate, the travelers on board would experience time slowing gently around them. Days aboard the ship becoming years back home, and distant stars drawing nearer in compressed distances. Inside such a vessel, the journey might feel peaceful, even quiet, as the universe shifts softly outside the windows. The stars ahead would seem brighter, their light gathered by the ship's swift approach. And from this imagined voyage, we drift toward the simplest, most graceful way light itself can push a spacecraft: the gentle pressure of sunlight. Fact 73. Solar sails in the dark light may be weightless, but it carries momentum, a soft push that can move objects across the void. Solar sails use this delicate pressure to travel without fuel, spreading out vast, reflective sheets that catch sunlight like a cosmic breeze. Each photon that bounces off the sail imparts a tiny nudge, and over time, those countless nudges add up, accelerating the ship ever so gently. The motion is quiet, graceful, almost meditative. A solar sail doesn't roar forward. It drifts, gathering speed in a slow, steady whisper, with no engines humming, no fuel burning, only starlight guides the journey. And from this serene propulsion, we drift toward an even more luminous idea: using lasers to push ships farther still. Fact 74. Laser-driven journeys. To reach distant stars within a human lifetime, sunlight alone may not be enough. Instead, scientists imagine powerful lasers stationed near Earth, shining beams of intense light onto enhanced solar sails. The pressure from these lasers would push the ship far faster than sunlight could, accelerating it to a significant fraction of the speed of light. The craft itself could be small and delicate, carried forward on a tide of controlled illumination. It is a gentle but ambitious dream. Starships propelled not by engines, but by focused beams of human-made starlight. Such vessels could explore nearby systems, sending back quiet updates across light years of distance. And from these imagined journeys, we turn to the nearest star that might one day receive our first interstellar sails. Fact 75. The distance to Proxima. Proxima Centauri, the closest star beyond our Sun, sits a little over 4 light years away, close in cosmic terms, yet unimaginably distant for us. Even traveling at a significant fraction of light speed, a journey there would take years from the traveler's perspective, and much longer for anyone waiting at home. Light itself needs more than 4 years to bridge the gap, carrying with it every message, every observation, every whisper of news. Thinking of this distance invites a sense of awe. Our closest neighbor is still far enough away that the present we see is already 4 years old. And from this vast reaching across space, we approach the gentle shifts in time that such travelers would experience during their long voyage. Fact 76. Time on the ship. For travelers, nearing the speed of light, time unfolds in a gentler rhythm. Days and weeks aboard the ship drift by quietly, while years, even decades, may pass back on Earth. This isn't a trick of perception, but a natural consequence of relativity. The faster the ship moves, the more slowly time flows inside it, like a calm pool sheltered from a rushing river. A journey that feels comfortably short to the travelers becomes a long stretch of history at home. This difference creates a bittersweet beauty. Voyagers would return younger than those they left behind, carrying stories from a journey experienced in a softened flow of time. And from this temporal drifting, we move to the challenge of communication across such vast, slow-changing distances. Fact 77. Messages between stars. Sending a message across interstellar space is like tossing a bottle into a vast cosmic ocean. Even at light speed, the fastest possible, signals take years to travel between stars. A ship heading toward Proxima Centauri might send updates home, but those messages would arrive 4 years after being sent. Replies would take another 4 years to return. It becomes a gentle conversation stretched across time, with long pauses and patient listening. This delay transforms communication into something almost meditative. Words must be chosen with care, knowing they will travel alone through the dark before reaching their destination. And from this slow exchange, we drift toward imagining what such communication might feel like on the scale of a whole galaxy. Fact 78. A galaxy-wide conversation. Across the Milky Way, stars are separated by tens of thousands of light years. If a civilization tried to speak to another on the far side of the galaxy, each message would take millennia to arrive. Entire cultures could rise, change, or disappear before a single exchange was complete. Light becomes both the messenger and the reminder of cosmic patience. Communication on this scale is less like conversation and more like sending postcards into deep time. Yet there is something peaceful in this thought. Even if answers come slowly, the act of sending a message becomes a gesture of connection across unimaginable distances. And from this long, lingering outreach, we drift into the possibility that some voices, once sent, may never be heard at all. Fact 79. Lost voices. In the vast quiet of the cosmos, many messages simply drift into silence. A civilization might send out signals, hopeful, curious, or simply exploratory. But if no one is listening in the right place, or at the right time, those signals continue traveling endlessly. As galaxies move apart and stars drift through their long orbits, the paths of potential listeners may never cross the beams of these ancient broadcasts. The messages become soft echoes with no ear to receive them. It isn't a sad fate. It's a peaceful drifting, like a whispered poem carried on a breeze that no one hears, yet still exists. And from these lonely signals, we turn toward the hopeful truth that sending them still matters. Fact 80. Light is a carrier of hope. Even when a signal may never be heard, Sending it can be an act of optimism. Light carries our curiosity into the dark, announcing that somewhere in the universe, beings are wondering, exploring, hoping. Every beam of radio waves, every laser pulse, every flicker of communication is a small reminder that we seek connection beyond our own world. These messages drift outward quietly, becoming part of the cosmic tapestry of gentle, persistent exploration. A single transmission may travel for millions of years, long after its senders are gone, becoming a tiny thread in the universe's long story. And from these threads of hope, we follow the path of particles that race alongside light, testing the very edges of speed itself. Fact 81. Cosmic rays that outrun us, scattered throughout space, are cosmic rays, high-energy particles launched from distant stars, supernovae, and mysterious cosmic events. Some of these particles travel at speeds incredibly close to that of light, covering vast distances with astonishing swiftness. Though they can never exceed light's speed, they approach it with such intensity that their clocks slow dramatically, allowing them to survive journeys that would normally be impossible for matter. These rays arrive at Earth as quiet visitors from far-off corners of the galaxy, carrying stories of powerful explosions and ancient astrophysical events. And from these near-light-speed travelers, we drift toward even more elusive messengers, neutrinos, the ghosts of the cosmos. Fact 82. The fleeting neutrino. Neutrinos are some of the universe's most elusive travelers. Tiny, nearly massless particles that slip through matter as if it were hardly there. They are born in the hearts of stars, in supernovae, and even in the quiet radioactive processes on Earth. Because they interact so rarely, they can cross entire planets without slowing down, moving at speeds incredibly close to the speed of light. To them, the universe is almost perfectly transparent. Every second, trillions of neutrinos pass through your body without leaving a trace, drifting gently along their ancient paths. And from these ghost-like voyagers, we move toward the vast architecture of the universe itself, shaped in part by the speed of light. Fact 83. The shape of the universe. The speed of light helps determine the geometry of the cosmos. Depending on the total amount of matter and energy, space can curve like a sphere, stretch like a saddle, or remain nearly flat. Observations tell us that the universe is astonishingly close to flat, meaning parallel lines stay parallel, and light moves across immense distances without looping back on itself. This shape influences how galaxies form, how the universe expands, and how far light can ultimately travel. A flat universe is one where light can glide quietly for billions of years, tracing straight paths across the cosmic canvas. And from this gentle geometry, we drift into regions where light behaves in the strangest ways, the gravity wells of black holes. Fact 84. Light in black hole realms. Near a black hole, gravity becomes so intense that space-time bends steeply inward. Light passing nearby follows these curves, spiraling and looping in paths that appear distorted and surreal. Some photons skim close enough to orbit the black hole in a delicate ring, held on a razor's edge between escape and capture. Others fall inward and never return, their journeys ending at the event horizon, where even light cannot climb back out. From the outside, these paths appear dreamlike, arcs and whirls carved into space-time by an invisible mass. And from this shadowed region, we move toward the place where the very last light manages to slip away. Fact 85. The the last light to escape. At the boundary of a black hole, the event horizon, gravity is so strong that not even light can break free. But just outside this invisible border, photons can still make a final attempt. Some skim dangerously close, stretching into long looping arcs before escaping with barely enough energy to reach the outside universe. These fragile beams carry stories from the very edge of no return, softened and reddened by their climb out of the deep gravitational well. To witness such light is to see a moment on the brink, a gentle farewell from regions where time and space twist profoundly. And from this delicate escape, we drift toward the glowing ring carved around black holes by captured light. Fact 86. The bright ring. When photons orbit a black hole or loop around its intense gravity, they form a glowing circle known as the photon ring. This halo is not made of matter, but of light trapped in elegant repeating paths, circling again and again before some rays eventually slip outward to distant eyes. When astronomers photographed the shadow of a black hole for the first time, it was this shimmering ring that outlined the darkness. The ring is a quiet masterpiece of relativity, a luminous boundary sculpted by the speed of light and the curve of space-time. Its soft glow marks where light dances on the very edge of the impossible. And from this ring of captured photons, we travel toward ripples that shake the universe itself. Fact 87. Gravitational waves. Join the dance. Gravitational waves are ripples in space-time, created when massive objects like black holes or neutron stars collide. These waves travel outward at the speed of light, carrying with them the faint, rhythmic signatures of cosmic events. Unlike light, they pass through matter effortlessly, vibrating the universe itself in tiny, delicate stretches and squeezes. Instruments like LIGO use laser beams to detect these subtle motions, revealing distant collisions through patterns quieter than a whisper. Gravitational waves remind us that the universe moves not only through beams of light, but through trembling pulses of space-time. And from these rippling echoes, we drift toward the comforting thought that everything, light, gravity, space, and time, shares the same cosmic speed. Fact 88. A universe of signals. Across the cosmos, countless signals travel outward, beams of light, pulses of radio waves, flashes of X-rays, and trembling threads of gravitational waves. Though their forms differ, they all obey the same ultimate speed. This shared limit creates a quiet harmony among the forces of nature. Whether a star explodes, a planet transits its sun, or two black holes merge in darkness, the news of these events moves through space at the same gentle pace. It is as if the universe has agreed upon a single tempo, a cosmic rhythm that keeps all messages aligned. And from this unified speed, we drift toward the farthest light we will ever be able to see. Fact 89. The farthest light we'll ever see. Because the universe has a beginning, and because light travels at a fixed speed, there is a limit to how far we can peer into the past. The oldest light in existence, the cosmic microwave background, is nearly 13.8 billion years old. It comes from a time when the universe first became transparent, allowing photons to wander freely. We cannot see beyond this horizon, not because the light is too faint, but because before that moment, the cosmos was opaque, like a fog too dense for photons to escape. This boundary is a quiet echo of the universe's first breath, a soft wall of ancient light that gently encloses our vision. And from this limit, we drift toward the growing darkness that someday will will hide even the galaxies we can now see. Fact 90. The future fading as billions of years pass. The universe will continue expanding, carrying distant galaxies farther and farther away from us. Their light will stretch into longer wavelengths, slipping beyond the reach of our eyes and instruments. One by one, these galaxies will fade from view, not because they vanish, but because their light can no longer keep pace with the expanding fabric of space. Eventually, only our local cluster of galaxies will remain visible. This gentle fading is not an ending. It is a quiet transformation, a soft dimming of the cosmic stage as time drifts onward. And from this imagined future, we move toward the deepest reflections on how light itself gives meaning to time, distance, and the unfolding story of the universe. Fact 91. The constant that creates time. The speed of light doesn't just guide the movement of photons, it shapes the very way time flows. In Einstein's equations, time and space are intertwined, and c is the thread that stitches them together. Without this cosmic constant, moments would lose their rhythm, distances would lose their meaning, and the universe would be unable to keep track of its own unfolding. Light provides the tempo, the heartbeat that tells space-time how to behave. Even though we rarely think about it, every passing second is quietly governed by this universal limit. And from this gentle foundation, we drift toward the idea that cause and effect follow their own soft, steady rhythm as well. Fact 92. The rhythm of causality. Causality, the simple truth that one event leads to another, depends entirely on the speed of light. Because no information can travel faster than c, the universe maintains a clear order of happenings. A star must shine before its light reaches us. A pulse of energy must be created before it can be felt. This gentle sequencing creates the smooth flow of time we experience, ensuring that the cosmos unfolds in a coherent, meaningful way. Causality acts like a quiet guardian, keeping the universe from tumbling into confusion. Light sets the pace, and everything else follows, step by gentle step. And from this ordered flow, we drift into the realization that all we see is shaped by the delays of light's long journey. Fact 93. Light is the universe's memory. Because light takes time to travel, everything we observe is a message from the past. We see the moon as it was a second ago, the sun as it was minutes ago, and distant galaxies as they were millennia or even eons ago. Light becomes a soft memory, carrying snapshots of moments long vanished, preserving them in gentle streams of photons that drift across space until they reach our waiting eyes. In this way, the universe is a living archive, with every beam of light acting as a tiny record of how things once were. The night sky becomes a tapestry of delayed moments, stitched together by time and distance. And from this notion of cosmic memory, we drift toward imagining worlds where the speed of light, this quiet storyteller, might have been different. Fact 94. Changing the constant. Imagine a universe where the speed of light were not the value we know, but something gentler or more extreme. If c were different, the entire structure of reality would shift. Stars would burn at different rates, planets might orbit differently, and even atoms could change their behavior. Light would take more or less time to cross the cosmos, altering the way galaxies form, collide, and evolve. The familiar dance of physics would hum to a new tempo. Though such a universe would still have its own beauty, it would not resemble ours. Its story would unfold under different rules, written in a different rhythm of space and time. And from this imagined cosmos, we drift toward a world where light slows, softening every motion. Fact 95. Slower light, softer worlds. If the speed of light were slower, everything we know would unfold in a gentler, more deliberate way. Information would take longer to travel, stretching communication across wider intervals. Stars might form more slowly, their internal balance shifting as energy escaped at a reduced pace. Even everyday actions, seeing, reacting, understanding, would be touched by this softened flow, as though the universe breathed in longer, quieter cycles. Distances would feel larger, horizons more distant, and the night sky would tell its stories with a longer echo. A slower sea would create a cosmos where patience is built into the very fabric of reality. And from this softened world, we drift toward the opposite extreme, a universe where light moves faster still. Fact 96. Faster light, wilder realities. If light traveled faster, the universe would be filled with a sharper, more energetic tempo. Information would race between points with astonishing speed, tightening the connections between distant regions. Stars might burn brighter and more intensely, releasing their energy with increased efficiency. Even the boundaries of galaxies could change, shaped by the swift exchange of light and gravity through space-time. In such a reality, the cosmos might feel lively and dynamic, unfolding in quick, vibrant pulses. Yet even here, harmony would remain. A new rhythm woven through the fabric of existence, guided by a faster cosmic heartbeat. And from this thought of alternate universes, we drift toward the final chapters of light's long future journey. Fact 97. Light and the multiverse. If our universe is only one of many, a vast collection of possible realities, then each might carry its own version of the speed of light. In some universes, C could be slower, giving rise to calmer cosmic evolutions. In others, it could be faster, allowing energy and structure to shape themselves in ways we can only imagine. Each universe would breathe to its own rhythm, guided by the rules that govern its space-time. This idea doesn't suggest chaos, but a quiet diversity. Countless realms, each unfolding in its own gentle harmony, with light speed as one of the notes in its unique cosmic song. And from this possibility, we drift toward the far future, where light continues its journey even as the cosmos grows dim. Fact 98. The final photons. As the universe expands and ages, stars will fade, galaxies will thin, and most sources of light will slowly vanish. Yet some photons, born in ancient stars, drifting across intergalactic space, will continue traveling, growing ever longer in wavelength as the cosmos stretches around them. These final beams will be soft beyond comprehension, carrying the faintest echoes of a universe long past its brightest days. Though nearly undetectable, these ancient photons will persist, wandering through a cosmos that grows colder and quieter with time. And following their lonely voyage, we approach the gentle twilight of all cosmic illumination. Fact 99. The end of the long glow. In the farthest reaches of time, long after the last star flickers out, the universe will settle into a calm, dark state. Light will still exist, but stretch so thin that its energy becomes barely distinguishable from the quiet fabric of space itself. The cosmos will not end abruptly. Instead, it will dim slowly, like embers cooling after a long and beautiful fire. Every photon that remains will carry the memory of a brighter era, drifting softly into the cosmic night. This long glow is the universe's gentle farewell, a serene transition rather than a sudden silence. And from this fading light, we move toward the final truth, the peaceful quiet that awaits in the darkness ahead. Fact 100. A quiet universe ahead. In the distant future, when the last traces of starlight have faded and the galaxies drift beyond one another's reach, the universe will settle into a deep, gentle stillness. No new suns will ignite, and no bright nebulae will shimmer through the dark. Yet even in this quiet, a few lingering photons, stretched thin by eons of expansion, will continue their slow, patient journey. They will drift through a cosmos that has grown spacious and calm, carrying the final memories of light's long story. In that tranquil darkness, the universe will not feel empty, only peaceful, a vast, resting sea after an age of brilliance. And from this final quiet, our own journey of sleepy facts comes softly to a close. And as our journey comes to a gentle close, I hope you found a bit of calm among the stars tonight. The universe is vast, mysterious, and full of wonders. Yet even its fastest light can feel soft and comforting when we explore it slowly, together. If you enjoyed drifting through these sleepy facts, don't forget to like the video, subscribe, and comment below what topic you'd love to fall asleep to next. Your suggestions help us shape new journeys for sleepy minds everywhere. When you're ready to keep dreaming, tap the end screen to watch the next sleepy astronaut video and continue your quiet voyage through the universe. Sweet dreams, and see you among the stars.